Motorcycle engines live close to the edge. A modern superbike must produce enormous power from a compact engine while remaining small enough to fit inside a lightweight chassis. The Ducati Panigale V4 R pushes that balance further than most production motorcycles ever attempt. At its core is the Desmosedici Stradale R engine. This is a 998 cubic centimeter V4 designed to mirror the architecture used in Ducati's MotoGP racing program. The engine can spin beyond 16,000 revolutions per minute under race conditions, an extraordinary number for a road-legal motorcycle. High engine speed allows more combustion cycles per second. More combustion cycles mean more power, but increasing RPM introduces mechanical stress. Every moving component inside the engine experiences greater acceleration forces as speed rises. Pistons must reverse direction thousands of times per minute. Connecting rods endure intense loads. Valve systems must open and close with extreme precision. At very high RPM, conventional valve springs struggle to keep up. Ducati solves this problem with its Desmosedici valve system. Instead of relying on springs to close valves, the Desmosedici mechanism uses mechanical linkages to both open and close them. This prevents valve float, a condition where valves fail to follow the camshaft profile at high speed. Without precise valve timing, engine performance collapses. But power is only part of the equation. A superbike must also remain stable at extreme speed. Motorcycles operate with only 2 contact patches touching the road. As velocity increases, aerodynamic forces begin to influence stability. Air pressure can lift the front wheel during acceleration, reducing steering control. To counter this effect, the Panigale V4 R uses aerodynamic winglets mounted on the front fairing. These winglets generate downforce as air flows over them, pushing the front tire toward the pavement at high speed. That added force improves stability during acceleration and braking. However, aerodynamic surfaces introduce drag. More drag reduces top speed and increases engine load. Engineers must balance aerodynamic stability with efficiency. Heat is another constraint. High RPM engines generate enormous thermal energy. Combustion temperatures rise, friction increases, and lubrication systems must work harder to protect internal components. Cooling systems circulate liquid through the engine block to remove excess heat. If temperatures climb too high, performance and reliability suffer. Then there is vibration. At high engine speeds, even tiny imbalances inside rotating assemblies can produce strong vibrations. Engineers must carefully balance the crankshaft, pistons, and other moving parts to prevent destructive resonance. Motorcycle frames must also manage these forces. The Panigale V4 R uses a lightweight aluminum chassis designed to maintain rigidity while minimizing weight. Reducing mass improves acceleration and cornering performance, but the frame must remain strong enough to handle engine output and suspension loads. Braking performance becomes equally critical. With speeds exceeding 180 miles per hour, approximately 290 kilometers per hour, on long straights, the braking system must dissipate huge amounts of kinetic energy. Large performance brake discs and advanced braking electronics help maintain control under extreme deceleration. Electronic control systems also play a major role. Modern superbikes use traction control, wheelie control, engine braking management, and ride-by-wire throttle systems. These electronic systems monitor wheel speed, lean angle, and throttle input to maintain stability. Without them, harnessing the engine's power would be far more difficult. The Ducati Panigale V4 R exists because racing regulations require manufacturers to produce road-legal versions of their competition machines. This process, called homologation, ensures that race bikes remain connected to production models. The result is a motorcycle that sits remarkably close to the edge of racing technology. But it cannot escape physics. High RPM increases mechanical stress. Aerodynamic surfaces improve stability but add drag. Thermal loads must be controlled to preserve engine life. Engineering a superbike means balancing speed, reliability, and control within a narrow performance window. The Panigale V4 R shows what happens when engineers push that window almost as far as it can go. And on two wheels, that margin for error is very small.